Truth Seeker Learning here. Today we're going to talk about writing equations from verbal expressions into algebraic expressions. So we're going from a written statement into an actual equation, and then we'll solve it. Now, an equation is a number sentence, okay? And it has a variable, which is a missing number. And your job is to figure out what that number is. So let's do some. A number x plus 5 is 13. Now, I told you in the last video that whenever we see the word sum, that means add, or add means add, obviously, it means addition. Sum means addition. Difference means subtraction. Greater than can also indicate subtraction, if we have to see, again, the difference. Product is multiply. Quotient is divide. Now, here's a new word here for you. Is. The word is. And the word is, in a verbal expression, means equal. It means you put an equal sign. So a number, we don't know what that number is, but they defined it as x. Now, we could have just put a number, and we could have put our own in, but they said x. Okay, so a number x plus, and of course plus means addition too, like sum, plus what? Plus the number 5 is equals 13. And that's how you write it. While we're at it, let's solve it. Let's solve it. Yes, I know we're going to have to just write them. Sometimes your teacher will just say, just write them. Just learn how to write them first. And that's true, but let's go ahead. Why be behind? Let's move ahead. Minus 5, because in algebra, we want to combine like terms, right? So it's minus 5, x equals, right? We take 5 from 13, and we have 8. Now, let me just say one thing. X plus 5 equals 13. In algebra, there's 4 steps to algebra. I'm going to do videos on doing algebraic equations, or algebra equations. And there's 4 steps to algebra. There is, well, I should say 3 steps. There's distribute, combine like terms, divide. So there's really 3 steps. Scratch that 4 steps. 3 steps. Distribute, combine like terms, divide. So this is combine like terms because I had nothing to distribute. So I just combined what I could combine. And the 5 and the 13 went together because why? Well, they're both numbers. So they go together. Right? Birds of a feather flock together. Which means people of like mind come together, and so do numbers. Let's see this. Let's see the next one. 15 less than a number. 15 less than a number. Y is 9. Now, I told you in the last video, whatever comes after the word than goes first when you go from a verbal to an algebraic. So, what comes after that word than? A number. Y. So I'm going to put Y. Y. 15 less than that Y. Minus 15. And then we have our little is, which means equal. Equals 9. Now let's solve it. Well, we have a 15 and a 9. So we can combine them because we're supposed to. There's no distribution here. And how do I know there's no distributing? Because there's no parentheses here. If there was a parentheses or even a bracket, then I would distribute, but I can't distribute here. So now I go plus 15, plus 15. Y equals, well, what's 9 and 15? That's easy. 24. So anyway, Y equals 24. In another video, I'm going to show you how to do the check, but not right now. Right now, I just want to make sure that you learn how to take a verbal equation, put it into algebraic form, and then solve it. And then we'll get to the whole thing about checking your answers, etc. Next one. So sum of 9 and a number 32. Now, notice in this case, I didn't define what the number was. I didn't put an X or a Y. Well, the book didn't put an X or a Y. And that can happen. So you can have the X or the Y, whatever the variable is, and you might not have it. And then you make one up, and that's okay. The sum of 9 and a number. Okay, sum means addition. So it's 9 and a number. I'm going to use X because that seems to be the most popular one. 9 plus X is 32. All right, no problemo. And then what do? Well, we could simply combine like terms. So let's do it. Now, why am I doing this? Because whenever you go underneath an equal sign, you have to do the inverse of the number you're moving. So I'm literally moving the 9 to the 32. Right? It's like a little game. Take the 9, move it to the 32. Well, that's what I'm doing. So I'm minus 9, minus 9. Now let's subtract 9 from 2. Well, you can't do that. Borrow from here. This becomes a 2 and a 1. 9, 10, 11, 12. That's 3. Bring down the 2. 23. So X is 23. No big deal. All right, let's do another one. Now, again, you can stop this video when I write the verbal expression down, and then you can solve it and then see if you get the right answer. That's the best way to make use of this. Here's a good one. 35. Now, in this case, they didn't actually put the number. They wrote it in word form. $35 divided by a number is 7. My fancy 7. 35. Okay. Divided by a number. Now, when we have something being divided, we normally put our typical division symbol like this. But in this case, we're not going to do that. All right, because in algebra, really most of the time, I would say 99.9% of the time, I don't think I've ever seen it, but I'm sure it happens on occasion in certain special problems. You just put a line. So 35 divided by a number. All right, well, that's X. Because, well, it could be Y too, but I'm making it an X. 35 divided by X is 7. Okay? And now I want to solve. This one's a little different. Because the last, when you have an equation where it's addition or subtraction, you can distribute, combine like terms, divide. Well, in this case, we're not going to do that. This is easy. We have 35 divided by an X equals 7. So it's saying 35 divided by what number is 7. So what you do is, well, I'll show you. You're going to multiply the X times the 7. So you go 35 equals 7x. So I multiplied, these two. I went x times 7. Then after that, it says 35 equals 7 times what number? Now, 7 times what number? That's multiplication. So the opposite of that, the inverse, because whenever you want to move something across an equal sign, you do the inverse. So I want to move that 7. So I do the inverse, and I divide. 7 divided by 7. Cross out, bring it over here. X equals, let's put it over here in case you can't see it on the camera. X is 5. So this literally says 35 divided by 5 is 7. Well, we know that's true. Okay, we know that's true. I hope this is making sense to you at home. It's making sense to me, but it has to make sense to you. Here's an easy one. Okay. Twice a number X is 40. Whenever anything says twice, by the way, it means put a 2. Twice a number. That means 2 times a number. Is, of course, is what? Is 40. Twice a number is 40. So what number times 2 is 40? Well, you could figure that out at home. I mean, it's easy. But let's pretend you couldn't figure it out, right? And your teacher wants you to do the work, so we're going to do the work. 2 times x is 40. All right, so what we do is we want to bring the 2 over here because we want to divide it into the 20. Now, how do we remove it? Inverse operation. So this is multiplication. We do division. 2 divided by 2 is 1, of course, so we cross out. That becomes a 1x. 40 divided by 2 is 20. Easy, easy stuff. So that says 2 times 20 is 40. Well, you know that. You can figure that out at home. You're all bright. Oh, let's see another one here. We'll get a hard one. 10 more than twice a number is 85. Okay, 10 more than twice a number. Now, I see that then right away. I'm like, okay, I have to do whatever it says after the then first. So twice a number. So I do 2x. 10 more than that. Okay, more than means addition. Wait a minute, that's a little sloppy. 10 more than twice a number is equals 85. Okay, now let's solve it. We can't distribute. No, we don't have any parentheses or brackets, so now we're going to combine like terms. Let's bring the 10 to the 85. Of course. Now how do we do it? Inverse operation. Minus 10, minus 10. Bring the 2x down, of course. Never be lazy when you do math. Never be lazy. Sometimes you can take shortcuts, but it's best not to until you really know what you're doing because you could make a mistake. So bring the 2x down. Some students get sloppy and they leave it up there. Bring it down. I do everything out. I think that's the best way to go. Now, 85 minus 10, of course, is 75. Now we want to work that out. So let's see. 2 times what is 35? Well, this I can tell you right now it's not going to be even, but we want to do the inverse to get rid of the 2 and bring it over here. And let's see, now we're going to divide 75 by 2. So let's do it over here. 75. We'll do it out for you, because you can't always do these things in your head. 2 into 7. 2, 4, 6. 3. 3 times 2 is 6. Subtract the 1 is 7 minus 6 is 1. Bring the 5 down. 2 into 15. Well, 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. Well, 8 would be too much, so we'll put 7. 7 times 2 is 14. 15 minus 14 is 1. Add a decimal and a 0 to keep dividing. And I always tell students, bring the decimal up, and we're going to do division. We'll do basic. I'll do videos on addition, division, the whole thing. But I wanted to start with algebra because a lot of students have trouble with that first. Then I bring this to 0 down. 2 into 10. Well, that's even. It's 5. 5 times 2 is 10. Subtract. Boom. You're done. So the answer here is 37.5. And it's not even. It's not an even number like 32, 33, whatever. But in the sense that it doesn't have a decimal. 33, of course, cannot be divided in half. So technically it's not an even number, but what I mean is it doesn't have a decimal. Don't be afraid of that. That does happen in algebra. Students will look at that and say, oh, it must be wrong. No, it doesn't have to be wrong. It does not have to be wrong because we did everything right. We subtracted the 10, we got a 75. We divided a 2 into the 75, which is 37.5. All right, we'll do one more and then we'll call it a day. And we'll have other videos to work all this out. Here's a good one. Here's a good one. Here's a real good one. The sum of a number, excuse me, 1 minute. the sum of a number, to shut that off next time, the sum of a number and 5, the sum of a number and 5 divided by 8 is 13. Okay. The sum of a number and 5. So that's addition. A number, I keep putting x, and that's okay. The sum of a number and 5 divided by, we put the line, 8 is 13. A little more complicated, a little more complicated. Now, how do we solve this? 8 times 13. Let's do it over here. 13 times 8. Whenever I have this set up where I have an expression on top and then it's divided by a number or another variable, you just take that denominator and multiply it times whatever it equals. 8 times 3, 24. 8 times 1, 104. Right? 8 and 24. 8 times 1 is 8 plus 2 is 10. Okay, that's 104. So then it's excuse me. It's now I'm going to bring this down. X plus 5. X plus 5 equals 104. Okay. Now we'll combine like terms. Now, 5, take away 4, you can't do it. So you have to borrow from the 0. Well, the 0 has nothing, so I borrow from here. Comes a 0, this is a 10. Then that becomes a 9. Bring it over here, it's a 14. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 9. And then you bring the 9 down. So x is 99. Now let me just say one thing. I know I've been saying that when you do algebra, the steps generally are distribute, combine like terms, and divide. That's true when you just have simple addition and subtraction. But when you have division in here, it's multiply normally first when you have problems like this. So you have to, because there's different kinds of algebra problems, so you have to see which is which. In this case, this is the kind where you have a binomial divided by an 8 equaling a number. So then you have to multiply first, then you get this type of problem where you just have equation where you just have subtraction, addition or subtraction, and then you just distribute if you can, but you can't, you combine like terms, and then you divide. Okay, that's it for today. Sorry about the phone ringing. Please check out my website, truthseekerlearning.com. Later.